Okay, Elena is trying to prove the Pythagorean theorem. So when she does that, she knows that the goal is to prove that a squared plus b squared equals c squared in a right triangle. This is what she has so far, and so what we want to do is we want to fill in the blanks and finish the proof that she started. So we have a blank here, and we have a blank here. So she starts by saying in a right triangle, so this big triangle here is the right triangle she's talking about, the altitude that intersects the hypotenuse, so this is an altitude that intersects the hypotenuse, decomposes the triangle into two smaller right triangles. So basically what that's saying is that we get these two smaller right triangles when we draw the altitude in. These triangles are similar to the large triangle by angle-angle triangle similarity because each smaller triangle shares one angle with the larger triangle and a right angle. Similar triangles have proportional sides, so I know that what we can say here is, we're going to put this into a blank, we would have x over a is equal to, now x is this part right here, and a is this part right here. So we have the base and the hypotenuse, and it's going to be, we're going to talk about the big triangle, so the base and the hypotenuse. So this would be a over c. And in the other triangle, we have, let's see, b over y is equal to, so we have b over y, so we have the hypotenuse and kind of the back is equal to c over b, the hypotenuse and the back here. So c over b. So when we have a proportional relationship, the way that they're getting this right here is that you can take x times c, which is this part right here, and a times a. So we know that these two things are equal to each other, and the same thing for this proportion. B times b is b squared, y times c is yc. So therefore, if we add these two together, a squared plus b squared, it would have to be equal to xc plus yc. So here's where your algebra skills are going to come in. So a squared plus b squared plus b squared is equal to, now on this side you notice that both of these terms have a c in them, so we're going to undistribute that c, we're going to factor it out. So we have x plus y left over, so you can see that if we were to distribute this c back through, we would get xc plus yc. And we can see that x plus y is the same length as c. So we can substitute c in for this portion right here. Which leads us to a squared plus b squared equals c times c, which is the same thing as a squared plus b squared equals c squared.